Alright, this is going to be an introduction to vectors. So the most basic vector is called a unit vector. And it's a vector which has a length of 1. We'll call this unit vector A. Unit vectors are denoted with a caret over the top of them. And they're most used when talking with coordinate systems. So you have your standard 2D coordinate system with this being the x-axis and this the y-axis. So that's good for 2D, but in 3D, we have 3 directions. This being the x-axis, this could be our y-axis, and this could be our z-axis. And in this coordinate plane we have 3 unit vectors. One here, that's the I unit vector, it goes in the x direction. One here, J unit vector, goes in the y direction. And one more here, which is the K unit vector, which goes in the z direction. So if we just have some arbitrary vector, let's say this, and let's call it vector v, vectors are going to be denoted as the letter and then underline. So that's vector v. If we want to know the length of a vector, we just take the absolute value of that vector. That would be the notation. So the length of this vector, or more precisely the magnitude of a vector, is denoted by that. And this vector can be defined, this is the magnitude of vector v. So vector v can be defined in terms of these 3 unit vectors. So let's say vector v is equal to 3i plus 2j. So if we wanted to find the magnitude of it, basically what this is saying is if we have vector v right here, it could be made of, that's vector v, it could be made of 1, 2, 3 i's and 1, 2 j's. So I, j, j. So that's vector v. Now what that tells us, here's 3i, 2j. What's hopefully fairly obvious is that this length here can be found using the Pythagorean theorem. So if we wanted to find the length of vector v, we could just say that the length of vector v squared is equal to this side, so that's 3i all squared, plus this side, which is 2j squared. And since we know that I and j have a unit length of 1, we can say that the magnitude of vector v squared is equal to 3 squared plus 2 squared, which is equal to 9 plus 4, which gives you 13. So the magnitude of vector v is equal to the square root of 13. Now, we can also see that this vector has a slope of, say, slope of vector v is equal to 2 over 3. Now that's just because the slope is the rise over run. We have 2j in rise, 3I in run, so the slope is 2 over 3. Sometimes these things, the definition of the vector, this can be called a, and that can be called b. So the slope is b over a. So say we wanted to have a vector which goes in the same direction as vector v, but is a unit vector, so it only has a unit length of 1. We know that, let's do this. Example. Define a vector of unit length 1 in the direction of v. So we know that it has a unit length of 1, and if we want v hat, which is the unit vector of v, we just need to basically divide it by its own length, and that'll bring everything down to 1. So in order to do that, we take vector v and divide it by the magnitude of vector v. So we found the magnitude of vector v over here. So if we say that vector v is equal to what we said over here earlier, 3i plus 2j, and divide that by the absolute value of vector v, which is square root of 13. This right here is equal to this. And we can simplify that by saying that the unit vector v is equal to 3 over square root of 13i plus 2 over square root of 13j.